Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is differentiability. In this video, we'll be giving an introduction to this topic. What is derivative? Suppose f is a real function and c is a point in its domain, then the derivative at c is given by this formula. Let us observe this formula closely. This is a function c plus h. We are finding derivative at c and we are writing f of c plus h, where h is a very small quantity. H is something like delta h, very small. And what is again we are finding f of c divided by that small quantity. What does it represent? Let us try to understand with this graph. Let us plot this x and this as say f of x or y. Let us plot this one curve here, some function. Let this point be c and let this point be c plus h, so that this distance is h. What we see, this is the function value fc plus h at this point, and f of c is the value of the function at this point. Let us try to see this. So we are finding the difference. This is f of c plus h, this is f of c. So we are finding the difference here. So difference in the function value over a distance of h. So that's what we are doing. Suppose x is time. On the x-axis we have time. Then what is it? A change in the function value over the difference in time. So derivative, what is derivative? That means f dash x is change in function over the changing time. So what does it mean? It means the rate at which a function is changing is the derivative. So derivative is rate at which a function is changing. This is very important. So we'll see the application of this later. And what is a derivative of other trigonometric function like sin x? It is cos x. Cos x is minus sin x, tan x is sec square x, cot x is minus cosecant square x, sec x is secant tan x, and cosecant x is minus cot x cosecant x. Now important thing is, what is the derivative of x power n? So that is nx n minus 1. For example, we have x power 5. So its derivative will be 5x4. Can we use algebra of derivatives? Yes, there is algebra of derivatives. If u and v are two functions, then it's u and v are two functions. Let us take 2x square plus 3x cube. We have two functions. Can we find derivative of this? Yes. We write it by f dash x equal to 2 into 2 4x plus 9x square. So we can use this formula. We can segregate the two terms separately and then take derivatives independently. What if they are multiplying? For example, we have a function x sin x. Let us take f of x equal to x sin x. They are multiplying. So how do we do it? First function into derivative of second function plus second function into derivative of first function. So we can do easily. F dash x will be first function into derivative of second function, which is cos x, plus second function into derivative of first function, which is 1. So this is the answer. What about division? Suppose there are two functions dividing each other, then we can find the derivative using this formula. What is that formula? Denominator the whole square, then denominator into derivative of numerator minus numerator into derivative of denominator. We can take one simple example. So let us take f of x equal to sin x by x. So how do we do it? F dash x, we know we will use that formula. Denominator the whole square. Denominator into derivative of numerator is cos x, so x cos x, minus numerator into derivative of denominator, which is 1. So this is the answer. Now there is an important theorem that if a function f is differentiable at a point C, then it is also continuous at that point. This is very, very important. Derivative of composite function. What is a composite function? For example, we have y equal to say sine x square. We want to find derivative of this. So how do we do it? So this can be written as dy by dx. Previously we wrote f dash x. If y equal to some f of x, we can also write its derivative as dy by dx. So how to find dy by dx equal? Here we substitute, let us substitute t equal to x square. So what is dt by dx? Derivative of this function is 2x. We know that previously we have seen. So we can write this as y equal to sine t. So we can find dy by dt equal to cos t. But we want to find dy by dx. Originally function was with respect to x. We want to find dy by dx. So we can write, how we can write? We can write this as dy by dx equal to dy by dt into dt by dx. This is called chain rule. Observe that finally result will be dy by dx. These terms will get cancelled. Actually mathematically terms are not getting cancelled. These are just for the sake of explanation, that we can write chain rule like that. You cannot cancel this dt with this dt. That is wrong. It is totally wrong. Don't do it. But for the sake of understanding, you can write dy by dt into dt by dx, and dt is getting cancelled. So you get dy by dx. So what is dy by dt? We did it cos t. What is dt by dx is 2x. And what is t? T is x square. So we can write this as 2x cos x square. So this is the answer. Dy by dx is 2x by cos square. Actually we can do directly without going for the chain rule. When you become more experienced, it becomes very easy. We can directly do dy by dx as first function derivative, that is cos x square, we know, into derivative of this term, which is 2x. That's what we got here. So we can apply chain rule also, but when we become more experienced, we can solve it directly. What is implicit function? So far what we had been doing is explicit. For example, y equal to x cube minus x square plus 2. This is an explicit. What is explicit means? Explicit means y can be written directly as a function of x. Y is written as directly a function of x. So this is explicit. But what is implicit then? Implicit means we cannot write y explicitly like this. So for example, we have y square minus say sin x sin y equal to x cube. How do we write this as explicit function of y? We cannot write y and take all x on the right side. So how do we solve this? So we can solve this again using the derivative concept. So we will write, we have to find dy by dx. So we write it explicitly. We can write this as y square minus sin y minus x cube equal to 0. This is called an implicit function. So how do you find derivative? So take the first term. Its derivative is 2y. But it is finding derivative with respect to x. So we have to add dy by dx. What is derivative of sin y? Is cos y. Minus sign is there. So cos y dy by dx. What is derivative of this with respect to s? Is minus 3x square. This is equal to 0. So now we can combine dy by dx together and take the other terms and get the solution. This is called derivative of implicit functions. Now derivative of inverse trigonometric function. We have found derivatives of trigonometric functions earlier. These are for derivatives of inverse trigonometric functions. For example, d by dx sine inverse x is 1 by square root 1 minus x square. When we do for cos inverse, we add a negative sign here. What we got for sine inverse. Similarly for tan inverse, x derivative is 1 by 1 plus x square. Cot inverse x is minus 1 by 1 plus x square. Similarly for sec inverse x and cosecant inverse x. Friends, this was an introductory video on derivatives. We'll come to more examples later. Kindly like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.